So there have been a lot of discussions in the online communities about how to handle exceptions in the case of lambdas. We want lambdas to be really small and crisp one-line functions. But on the other hand, those functions could throw exceptions and we want to handle the exception. Now, the only way you can handle exceptions in Java is by using a try-catch block, which means that our one-line lambda becomes a 5-line monstrosity of try and catch that looks like this, which is not nice. So here's a solution. And of course, you can feel free to come up with your own solution. There are multiple ways to handle this. Now, let's say I take this out and have this lambda still be that elegant one-liner that we have seen before. Get rid of this. And this is a very elegant lambda. Now, instead of having the try-catch happen over here itself, what if I were to externalize the try-catch into a separate function and then wrap this lambda with another lambda that has the try-catch? You heard that right. I said wrap a lambda in another lambda. How does that work? Well, here's how it works. Now let's say I have another lambda here, which is a wrapper lambda. Okay, so let me call this private static wrapper lambda. Let's look at what the type is in a little bit. But what this does is it basically takes the same type as the lambda that it needs to wrap. So I'm going to accept this. It's basically going to be a by consumer. Now, what if I were to just return what I'm accepting? Now, this consumer is a lambda expression. It's a value which contains a lambda expression. Now, let's say I just return consumer. And what's the return type now? It is by consumer of integer. It's basically taking in a by consumer of 2 integers and it's returning the same thing. Okay, it's basically a pass-through. Now, if this were to happen, can I do this? Can I, instead of passing in this lambda expression, pass in a wrapper lambda of the lambda expression? Would this work? It would work, because what will happen is this wrapper lambda is the method that gets called with the lambda expression that's passed in. And what does this method do? It just returns the lambda expression that's passed in. So it is accepting a by consumer and it's returning a by consumer. So this is essentially a no op. So if this gets sent to the process method, it's basically doing a no op. All right. So let's execute this to make sure this still works. Well, we now have a divide by 0. So let me change this to a valid key and make sure this still works. Yes, this still works. So this is essentially doing a no op. But here's another thing I can do. Rather than pass in a consumer, I can actually create a new lambda. Now let's say I create a new lambda here. I'd say A and B. I'm going to say system.out println of A plus B. Okay, so what the lambda we passed in was something that takes in 2 arguments. Let me call it the same argument so that there's no confusion. It should be nk, and I'm going to use vnk here, right? So what was passed to a wrapper lambda was this lambda. It takes in 2 arguments and it prints the division. But what I'm doing is, rather than passing it through, I'm replacing it with something else. I'm creating a new lambda here which adds those 2 numbers up. And if I were to pass wrapper lambda off this lambda expression, this basically takes this lambda expression, ignores it, throws it away, creates a new lambda expression, and that is what's passed to process. So when process takes in the consumer, it's taking in this lambda expression that the wrapper lambda created. So when consumer.accept is called, what gets executed is this print of the sum. So let's execute this and make sure it's the sum that's getting printed. So it is. Now, why am I doing all this? The reason I'm doing this is to illustrate that you can have this kind of a pass-through function which creates a new lambda expression. Rather than totally ignoring what's passed in and creating a new lambda expression, what I can do is execute whatever's passed in. Consumer.accept of v and k. Now what am I doing? This is a true wrapper now. I'm basically creating a new lambda expression which only does what the consumer does, right? So it's an unnecessary wrapper in this case. So it's basically creating a new Lambda expression which executes what it's passed in. And this is what gets passed into process. So I'm basically wrapping this Lambda expression with a new Lambda expression. So when process takes in the consumer, it gets the wrapper. And when it does consumer.accept, what Lambda expression gets called? It's this one. And that takes in these two arguments. And that says, okay, I have a consumer. Now I need to execute the accept on this. Now what is this consumer? It is this Lambda expression that was initially passed in. So it's going to come to that. And that is going to do a v/k. So it's basically adding an extra layer, an extra wrapper around whatever you passed in line over here. So since it's not doing anything else, since it's just executing what the consumer passed in, it should basically return the same thing. It should just do integer division. All right. So you can do something fancy like adding some extra lines. I can say system.out.println of executing from wrapper. Now what's going to happen is this wrapper is going to do one more thing, and then it's going to execute what it was actually wrapping. So in this case, I'm going to get this executing from wrapper printed for each time this Lambda expression runs inside that wrapper. So if I were to run this, you see this? Every time the wrapper executes, and then it does the consumer.accept of the original Lambda, and that original Lambda executes, which is over here. Now why am I doing all this? Now this should give you an idea. Why did we start this conversation? We were looking at doing a try catch. Now isn't this a good place to do a try catch? Now I can isolate this thing out into a separate wrapper Lambda, and I can do the try catch in the wrapper Lambda so that when you're passing in the actual Lambda to the actual function, you don't have to do the try catch. So let's say I do something like this. I have a try block here, and then I execute the original Lambda inside the try block, and then I catch an exception here. And then here I print the error message. Exception caught in the wrapper Lambda. So what's going to happen is the process is going to get a wrapped Lambda. Now when consumer is executed by calling the accept, this is what gets executed. Now what is this? It's a try catch block. Now what does this execute? It does the actual inner Lambda, consumer.accept, which is this guy. Now if this executes successfully, well, everybody's happy. But if this were to throw an exception, well, guess what? We have a try catch here, and this catch is going to get executed, and we're going to get this system.out. Now this again should not change the execution the way we have it now, but if I were to change the key to 0 and execute this again, you can see that the exception is caught in the wrapper Lambda. So the original Lambda is pretty much free of try catch. So it's still crisp and short, but you're basically moving the try catch to another Lambda. Now you might argue that you haven't made the complexity any simpler. It's still the same thing, you just moved it to another location. But I wanted to highlight that this is one of the ways in which you can solve this. Another thing you can do is have a wrapper Lambda be a generic method. Right now it's just doing integer, right, by consumer of integers. You can have this be a generic method so that you can pass in any types, and for any by consumer Lambda, you can have a wrapper which handles exceptions for that by consumer by making this whole thing be generic. I'm not sure why these wrappers weren't shipped into the JDK. Just like you have a by consumer interface that comes out of the box with the generics, we could also have a by consumer wrapper shipped out of the box with the generics. But the JDK, the Java language designers, decided not to do that, and it is what it is. But we can leverage the same concept and write these wrappers with generic methods so that it can be used in multiple locations.